Hi, this is Ms. Delosier, and these are your notes on conservation of momentum and collisions. These are the last notes that we're going to do on momentum. I know it's been a really long unit as far as notes go, so let's go ahead and get started. Conservation of momentum is a law, and it's just like any of the other laws of conservation. It basically says that whatever you start with, you have to end with. There's a slight caveat here in the law of conservation of momentum. It's basically when there are no external forces, the momentum before an event has to equal the momentum after an event. The total momentum before equals the total momentum after. Now the equation, this is the equation that they give you on the formula chart. Here it is. It says mass 1 times velocity 1 initial plus mass 2 times velocity 2 initial is equal to the mass 1 times the velocity 1 final plus the mass 2 times velocity 2 final. And that's a big, long, massive equation, and I know it's pretty scary looking. And all it's saying is that if I have a mass, its initial velocity, and then I have another mass and its initial velocity, their final velocities and masses have to equal a sum total at the end. So what I have before from two masses and two velocities has to equal what I have after for two masses and two velocities. And we're going to do some practice problems with this, so you're going to have an opportunity to apply it. It's just the initial, like the additional subscripts for initial and final are confusing to you, and I understand that. So let's look. If I have a car and it has a mass of 1,815 kilograms, and I have the juggernaut, and his mass is 225 kilograms, and the juggernaut is traveling at 15 meters per second towards the car, and the car is not moving, what's going to happen? I think you all know that juggernaut's basically going to cream the car, and he's just going to take it out, and it's going to keep moving to the left, right? So he's just going to smash into the car and just shove the car out of the way, right? So let's go ahead and figure out what that would look like mathematically. So we have m1v1 plus m2v2 equals m1 plus m2, and then my velocity final. So here's what I've got going on. m1v1 is the mass of the car and how fast the car is going. m2v2 is the mass of the juggernaut and how fast the juggernaut's going. At the end, I'm going to have the juggernaut shoving the car, right? So I have to consider them a combined mass. They're stuck together at that point. So that's just one big mass, and it's moving at one velocity at that point. So I would say the total mass times the total velocity for them. So let's figure out how to solve for that. And what I'm going to be solving for in this is v final. So if I say that I have the car's mass, 1815, going at 0 meters per second, plus the juggernaut, and he's going at negative 15 because he's going to the west direction in the way I drew it. So that's a negative. And that's going to equal the total, 1815 plus 225 times the final velocity, and that's what we're trying to solve for. So that's going to equal 0 minus 337, which is going to equal 2040. So 2040 is my total mass at the end, times the velocity. So let's divide through and let's solve. And what that's going to give me is that my final velocity is going to be negative 1.65. So really what this means is that the juggernaut's going to end up moving himself and the car at a speed of 1.65 meters per second. So basically what happens is the juggernaut runs really fast at the car's not moving, he slams into the car, and then he keeps going at 1.65 meters per second in the same direction he was running. And that's all that says. So let's look at what that means conceptually and do a couple more practice examples. So if I have the car again and the juggernaut again, and let's say that the juggernaut's moving at 25 meters per second, and this time the car's moving at 2 meters per second. And my question is, how fast is the car going afterwards if afterwards the juggernaut is going at 1 meter per second towards the left still, So now I'm going to use that full equation that we started with, right? And I'm going to plug everything in except the velocity of the car at the end. Okay? So I know that the car is 1815 to begin with, and it's going 2 meters per second. I know the juggernaut's 225, and he's going negative 25 to begin with. And then I know that the car at the end is 1815. And I don't know how fast it's going or in which direction it's going. But I know the Juggernaut's going 225, and I know he's still going to the left. So I'm just going to solve. I'm just going to solve for V. So let's go ahead and let's work through that. And I'm going to end up getting that negative 1770 equals 1815V, which means velocity equals negative 0.98 or 0.98 meters per second to the left. So the Juggernaut wins, and the Juggernaut wins by quite a lot still, because he still ends up moving the car, but he's not stuck to the car anymore. They're not in one continuous mass. So let's go ahead and look at some collision information.